Okay, welcome Chem8 to a short video on balancing non-standard organic combustion reactions between a complex organic molecule shown here. All right, and you'll notice this is different than the alkanes. And remember, the reason that we're reviewing this is not a waste of your time. This is super critical to the common exam that you're going to take next week. So we have a non-standard organic molecule that's going to be combusted. Remember that, and what makes it non-standard from the alkanes, you can see the oxygen here, right? Here's an O. That's what makes this non-standard. The alkanes are composed entirely of carbon and hydrogen. And if your knee-jerk reaction at this moment is to go, what is an alkane? You need to remember that this has already been reviewed, and there was a video that was put into your stream, and you were actually told a while ago to review this material. You should have all 10 of the alkanes memorized and be really comfortable in terms of how you balance those. The non-standards are tricky. I gave you some rules for the balancing of alkanes, and they don't apply here. So you don't want to just like arbitrarily apply those rules. So I'm going to give you a guidance, and this is not a black and white rule. I repeat, it is not a black and white rule, but in general, right? Because balancing these is really a pain in the neck, and you guys are going to need to practice this. You can go on the internet and find all kinds of uh, potential organic molecules, and you can try to balance them. I would recommend doing that before you get into this 15-minute time thing next week. But in general, what you're going to do is place, and I'm going to change colors for this, a 1 in front of the organic molecule. And I'm just going to abbreviate this way. And okay, I better add, for the memorizers, I better add a point here. So this is number 1. Number 2, you're going to add the 1 regardless of whether the C is odd or even. Now this is different than the alkanes, and I'm not going to go on and on about that in here. You were supposed to have done the review, and I know a lot of you are just blowing that kind of stuff off. So if you're in the category of the blow-offs, you're going to need to go back and review the alkane business. So I'm going to place a 1 here. Now, what does that mean? So remember, we're going to skip over the O2. There's 2 things with the non-standard here. We're going to skip over the O2, and don't forget that there's an oxygen in this molecule. But we're going to skip over the reactants for now and go directly to the CO2, and we'll place a 27 here because that balances the carbons against what we see here in the non-standard organic molecule. And then for the H2, we see that we're at 46. Remember that in water, the H's are represented by a 2, so we need to cut that in half, so we're going to put a 23 here. Now we need to count the oxygens that are on the product side of the reaction, and for the CO2s, we're going to have a total of 54 O's, right? Because it's 2 times 27. And for the hydrogens, we're going to have 23 O's, because the O here is represented by a subscript of 1. All right, so there's going to be 23 O's. The grand total here, when we add them up, right, and we need to do that, we need to sum them together, is 77. All right, now, so what we're going to do, because remember we have a single O here, so what I'm going to do is put a 38 in front of the O2s, and when we multiply the 38 by 2, what do we get? We get 76 total O's right here, which is not 77. But don't forget, we have a singular O here. So it's going to be 1 plus 76 to equal 77. And that's where the two numbers are the same. Okay, like I said, I am not going to go out into the internet for you and find tons and tons of these non-standard organic molecules. My recommendation is you spend like a half an hour or even an hour pulling some of those down and going through the balancing and make sure that you can balance a non-standard organic compound. Also, remember that anytime you combust something that's organic, right? So all organic combustions result in products that include CO2 and H2O. Yes, indeedo. So I'm going to go ahead and close the video.